So I'm talking very briefly about the feasibility and the impacts of near real-time monitoring on global infrastructure. So this is a big change, I think, in the industry, going from historical analysis to forward-thinking monitoring to proactive monitoring. It's something that's obviously possible on a long time scale. So when we're talking about months or years, it's been possible for a long time. But when we are moving to talking about days and weeks, that's when it gets much more challenging in terms of feasibility. So that's what I'd like to discuss briefly in my few minutes here. So the feasibility really comes down to a few separate sections. We've got the acquisition, the processing, and the delivery of the data at the end. So acquisition, this depending on your satellite of choice, is either most commonly Sentinel-1 or TerraSAR for high-res images. And so some of these providers have been offering rapid orbits. So that means that when the acquisition comes in at, let's say, 6 p.m., you have it in-house by 6 a.m. the next morning. So this obviously has a much faster turnaround than the normal 6 to 8 days that you may have on a normal, for your normal orbit delivery type, scientific orbits. And then you have image ingestion into your system. So you need to have a system that can recognize that these new images have came in, connect to the servers, download them through high-speed internet, and put them into your system in whatever pipeline you have in a way that can manage it. Which sounds easier than it is, I think, when you're talking about large amounts of data for many different projects at once, obviously. And then you have the processing, so co-registration, which is commonly one of the more processing intense tasks, the processing itself. So whether you're doing PSI, SBAS, DINSAR, whatever, these all take time. SBAS obviously takes much longer than some of the others, but even that we've got down to on the order of 4 or 5 hours to process a large TerraSAR stack over an area. And then you have iteration. So you never want to just deliver the first iteration you give. You need to check the results and you need to iterate upon it. And then you need to put it through quality control. So you have all these steps you need to do to be able to deliver professional, reliable data to a customer at a fast turnaround. And so these are all things that need to go into the thought process as you are building and optimizing your pipeline. And then you have the post-processing. You rarely want to deliver just a interferogram to a customer. You want to deliver the actual insights, the things they care about, and answers to their questions. I'm going to go into a few examples after this, just of the kind of cases which this near real-time monitoring has actually had impact on. Yes, there's a few different ways you can deliver this data, whether it's post-processing, reporting, interactive viewers, and all these things. If you want to have near real-time monitoring, they also need to be automatic and generated quickly. You can't be writing a 10-page report for a customer if you're expecting a like let's say a 2-day turnaround or something. And so that's the other part of this is you can just deliver an interferogram, but it's not that useful for them. So then we get into the impacts. So once you've managed to get your pipeline down from days or weeks down to hours or days, as I said, we can the longest time. If I go back 1 second here, the longest thing is still the acquisition. It's 12 hours to get from the image actually being acquired by the satellite and getting it in the house, even for the rapid orbits. And then we can deliver within another 12 hours. So everything from co-registration, processing, iterations, quality control, reporting, getting into viewers, all that is in the other 12 hours. So the biggest the biggest issue is still the acquisition and delivery to us time. But so the impacts already become really clear when you're talking about a 24-hour turnaround on these kind of data sets. You go from giving a once monthly update to being able to actively guide the on-site activities of these big projects. So we use this for sinkholes in Zambia on some mining projects where they are worried about sinkholes opening up in their areas, and we can guide them while sinkholes are forming about the current level of deformation. Obviously, the final on-site decisions is not ours, but I think it's a big help to these groups to have almost real-time information about what is happening. We also work with companies on injector failures in Californian petroleum systems. So being able to actively update them when they have an injector failure and they start having ground swelling around that injector, so they can go out and turn off the injector before they have environmental damage caused by surface expressions. So these kind of things, rather than saying, looking backwards to them, hey, you could have seen some uplift in this area, we can actually see it ourselves and warn them before that causes a problem. And then other completely different example again, so urban tunneling in Sweden. So we work with a group there on a major urban tunneling project where they need to grout into the side of the tunneling walls to strengthen the walls of the tunnel, push out groundwater. And so too little, you get substance. Too much, you get damage to the walls, and also you may get uplift. And so by having near real-time monitoring, they can control their grouting pressure to stop damage of the buildings above the tunnel complex that they're drilling. So these are all examples, and there are many more of cases where near real-time monitoring is more than just a operational activity. It's more than just a hey, we can do it fast. It actually has a big impact on different groups around the world. And so that's why I thought that this was a good topic for this presentation, was to discuss the actual impacts of speeding up your INSAR pipeline, going from days and weeks to put out good quality data to going to hours, on the order of hours, to be able to do this. And that is, we've seen that has a really big impact. So I'm looking forward to chatting to more of you about your thoughts on this as well. Thank you for your time.